Hi everyone, Assalamualaikum. In this video, we are going to discuss example for integration by U substitution. Alright, now we look at example 1. Evaluate integration of 3x over x squared plus 1 dx. Alright, from the given question, this is division function. And we have integration sign here, means we want to integrate. Okay. Be careful, never use quotient rule to integrate as in differentiation because there is no quotient rule in integration. So quotient rule is not allowed to integrate, right? In this case, we can use U substitution since the degree of x in numerator less 1 from the degree of x in denominator. So they can be related with derivative, right? Alright, when we use U substitution, we need to choose the correct U. Okay, in this case, our U equals to x squared plus 1. Because when we differentiate U with respect to x, then we have du over dx, it is equals to 2x. Okay, then we need to write dx as a subject. So we have dx equals to du over 2x. And after that, we need to rewrite the given question in terms of u and du. Alright, from the given question, we replace u equals to x squared plus 1. Okay, and then we replace dx equals to du over 2x. Alright, after that, we can simplify x from numerator and x from denominator. That's why we choose u equals to x squared plus 1 because when we differentiate, we have term containing x and term containing x here can simplify with x from numerator. Alright, so after we simplify, okay, and before that, if we make the right choice of u here, we can simplify or we can eliminate whatever x from the given question, right? So after we simplify whatever x, so we get 3 over u times du over 2. Then we can move out constant 3 over 2 from integration sign. Then we get 3 over 2 integration of 1 over u du, right? Now we have all term in whatever u and du, no more whatever x. So we can integrate with respect to u. Alright, from the given formula, we have integration of u to the power of negative 1 du equals to, we can write into the form of integration of 1 over u du, and it is equals to ln u plus c. Okay, we put plus c here because this is indefinite integral because no lower and upper limit. Alright, so after we integrate, so we still have constant 3 over 2 here, and then we get ln and then u plus c. Okay, we put u in modulus sign because ln negative is error. So that's why we must put modulus sign so that ln here always positive value. Okay, alright, after that, we replace back u equals to x squared plus 1. So we get 3 over 2 ln x squared plus 1 plus c. Alright, so this is the final answer. Okay, alright, this is division function, but we cannot separate because we have two terms in denominator here. Okay, so in this case, we can use U substitution, okay, because the degree of numerator less 1 from the degree of denominator, so we can relate with derivative. Okay, alright, from the given question, let's say we try another choice of u. Okay, let's say we try u equals to 3x. Okay, let's say if we have no idea to choose the correct u, let's say we try with u equals to 3x. So after we choose u, we need to differentiate. Okay, so we have du over dx. Okay, and when we differentiate 3x, it is equals to 3. And after that, when we use u substitution, we need to write dx as a subject. First, we define u, and then we differentiate du over dx, and then we write dx as a subject. So, after we write dx as a subject, so we have du over 3. We just cross multiply here, right? And after that, when we use u substitution, after we choose the correct u, and then we differentiate du over dx, and then we write dx as a subject, and then we need to rewrite the given question in terms of u and du, right? The original question give in terms of x and dx. So now we rewrite the given question in terms of u and du. So after we rewrite the given question in terms of u and du, alright, we have 3x equals to u here. So we write 3x equals to u. And then we still have denominator x squared plus 1. And then dx from here equals to du over 3. So we substitute here. Okay. But at this point, okay, we cannot simplify variable x here. So if we make the wrong choice of u, we can't simplify or we can't eliminate all the variable x from the given question. Means this is wrong choice, right? Right now, we continue with example 2. Evaluate integration of sin x cos x plus 1 bracket to the power of 4 dx, right? Right, from the given question, okay, this is multiplication function, okay, and we have integration sign here, means we want to integrate, alright. So be careful, never use product rule or generalized power rule to integrate, as in differentiation, because in integration, no product rule, no quotient rule, and no generalized power rule, okay. Alright, so from here, we have the power of 4 here, okay. So we cannot expand, okay, because has bracket to the power of 4. Or maybe we capable to expand to the power of 4 here, alright. So in this case, we can use u substitution since the functions sin x and cos x can be related with derivative, okay. Alright, so in this case, let's say we choose u equals to cos x plus 1. Okay, after we choose u, we need to differentiate. So from variable u and x here, when we differentiate, we get du over dx. Okay, equals to, when we differentiate cos x, it is equals to negative sin x. And when we differentiate constant, it is equals to 0. And no need to write. So we just write negative sin x here. After that, we write dx as a subject, okay? And we cross multiply here, so we get dx equals to du over negative sin x, okay? When we use u substitution, first we choose the correct u. After that, we differentiate, so we get du over dx. And then we write dx as a subject. And after that, we rewrite the given question in terms of u and du. From the given question, we have variable x and dx. Now, we need to write in terms of u and du when we use u substitution. Alright? So, from the given question, our u, we choose equals to cos x plus 1. So, means from here, cos x plus 1, we can write u and then to the power of 4. Okay, we still have sin x here. And then dx, we replace by du over negative sin x. Okay. And after that, we can simplify sin x here and sin x in denominator here. Okay. So if we make the right choice of u, we can simplify or eliminate all the variable x from the given question. So now, we can simplify variable x from the given question. Means we choose the correct u. Okay. Alright, after we simplify sin x, and then we move negative sign here, we move out from integration sign. So we get negative integration of u to the power of 4 du. Okay. And then from here, now we have all term containing u and du. So we can integrate from this point. Okay. So we integrate with respect to u. Okay. From here, we use formula integration of u to the power of n du equals to u to the power of n plus 1 over n plus 1 plus c. This is power rule. Okay. And we use this formula when n not equals to negative 1. Okay. And 4 here means not equals to negative 1. Okay. So if n here not equals to negative 1 or any value except negative 1, we can use power rule. Okay. Power rule in integration, we need to add 1, okay, from the original power. Okay. So when we use this formula, so we still have negative in front here, and then when we integrate u to the power of 4 from this formula, so we get u to the power of 5 over 5 plus c. Okay. And after that, we replace back, okay, u equals to cos x plus 1. So after we replace u in terms of variable x, so we get negative 1 over 5, and then u equals to cos x plus 1 bracket to the power of 5 plus c. Alright? This is the final answer. Okay? The original question is given in terms of x. So the final answer should be in terms of variable x. So that's why after we integrate, we replace back u in terms of variable x. Alright? From the previous slide, we choose u equals to cos x plus 1. Okay, then we get u to the power of 4 here, and then we can simplify. After we differentiate, we can simplify sin x here. Let's say we have no idea to choose the correct u. Okay, let's try another choice of u. Okay. Alright, so in this case, let's say we try u equals to cos x. Okay, so after we choose u, we need to differentiate. So we find du over dx, which is equals to negative sin x when we differentiate cos x. After that, we need to write dx as a subject. So we have du over negative sin x. Every time when we use u substitution, first we choose u, and then we differentiate, and then we write dx as a subject. After that, we rewrite the given question in terms of u and du. In this case, the given question is in terms of variable x and dx. So when we use u substitution, we rewrite the given question in terms of u and du. Alright? So from the given question, we have sin x here, and then cos x here, we replace by u. So we write u and then plus 1 bracket to the power of 4. And then dx here, we replace by du over negative sin x. Okay. Then we can simplify sin x and sin x in denominator here. And then we move out negative sign. So we get negative integration of u plus 1 bracket to the power of 4 and then du. Okay. Alright, in this case, we can simplify sin x, okay? Because when we differentiate cos x, we get negative sin x here. So we can simplify sin x here. And then in this case, we still have variable u and du, alright? But are we capable to expanding u plus 1 to the power of 4 or use u substitution again? Because this is integration question. Okay, so in integration, there is no generalized power rule. Okay, in differentiation, if we have bracket to the power of 4, we no need to expand, but we can use generalized power rule. That is in differentiation. But for integration, generalized power rule is not allowed. Alright? So, if we want to integrate this question, we need to either expanding u plus 1 to the power of 4, or we need to use u substitution again. Okay. So, are we capable to do that? Okay. So, the choice of u equals to cos x in this case is incorrect. So that's why in the previous slide, we choose u equals to cos x plus 1. So that we have single u here and then to the power of 4. Because when we differentiate 1, it gives 0 here. Okay, so nothing here. So when we differentiate, we still have negative sign x in the previous slide. Alright? Right, so instead of we choose cos x, so we better choose cos x plus 1. So that when we choose cos x plus 1, we still have, when we differentiate, we still have negative sign x only. Because when, let's say, if we have plus 1 here, when we differentiate is 0. Okay? Alright. So in this case, okay, we cannot integrate this, or maybe we're not capable to expanding this. Okay? So in this case, u equals to cos x is incorrect. Okay? Alright, let's say we try another choice of u. How about if we try u equals to sin x? Okay, from here. Okay? U must equals to the function inside the given question. Let's say now we try u equals to sin x. Okay? After we choose u, we need to differentiate. So we get cos x. And then we write dx as a subject. So we get du over cos x. Okay? And then we rewrite the given question in terms of variable u and du. Remember, when we use u substitution, first we choose u. And then we find du over dx, and then we write dx as a subject, and after that, we rewrite the given question in terms of u and du. Okay, but to write dx in terms of du, we cannot just simply replace like that. Okay, we need to differentiate from here to create symbol for du here. Okay. Alright, so from the given question here, after we rewrite in terms of u and du, so our u equals to sin x. So we write sin x equals to u here. And then cos 1 plus 1 bracket to the power of 4, and then dx equals to du over cos x. Okay, but in this case, can we simplify cos x here in bracket here and cos x in denominator here? Okay. So in this case, if we make the wrong choice of u, we can't simplify or eliminate all the variable x from the given question. We stuck here. Okay? Alright, so we cannot go from here. Okay? Means u equals to sin x is a wrong choice. Okay? Got it? So that's how we choose the correct u. Okay? Coming up next, more examples for integration by u substitution. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.